Hello, and welcome to the online course, Causal Inference from Observational Studies, NICER 201 COSIC. We're talking about confidence intervals. This is the second session where we'll talk about how to interpret confidence intervals. In order to interpret confidence intervals, we need to be mindful of two things. First, we need to look at the width of the confidence interval. A narrow confidence interval implies high precision, whereas a wide confidence interval implies poor precision. For example, as we saw in the first session, we had a mean cholesterol level of 150. In the first study, we had a confidence interval of 120 to 180, whereas in the second study, we had a confidence interval of 144 to 156. So the second study has a narrow confidence interval, which means we have estimated our estimate of mean 150 with a high precision, whereas in the second study, it is a wider confidence interval of 120 to 180. And usually we get a wide confidence interval or a mean value or the parameter of interest with poor precision, usually because of the sample size is not adequate. The second thing that we need to be mindful while interpreting confidence intervals is whether this interval contains a value, what is called as the null value, which means a value that implies that effect or association is not present. Now, if you are trying to look at difference between two means, and you're saying whether one mean is different, bigger or smaller than the other mean, the null value there would be 0. The null value for a difference in two values is 0. So we would like to see there whether this confidence interval, does it include 0 or not in the range that is calculated. When we're calculating the confidence intervals for ratio measures, like odds ratios, risk ratios, weight ratios, prevalence ratios, then the null value would be when the numerator and denominator are the same, which means the actual value would be 1. So for ratio measures, the null value is 1, and we would want to know whether the confidence interval that we have estimated, does it include 1 or not. We need to see so as I said, how narrow or wide is our confidence interval, and does it include the null or does it not include the null? So assume that here the red line, the red vertical line implies the null value, and then the arrow, the two-headed arrow, is the confidence interval. Let's take example here of, let's say this is a risk ratio. So the red line implies a value of risk ratio as 1. The area towards the right of the red line would imply values more than 1, and to the left of the red line would imply values less than 1. And when you have a risk ratio more than 1, that means there is a positive association. A risk ratio less than 1 indicates a negative association. So in the first, if your confidence intervals lies totally towards the right side and it does not include the null value, so here then we can say that there is a definitive positive association or a positive effect of the exposure of the outcome. Conversely, again, if the confidence interval is totally towards the left of the null value, which means the range of confidence interval is less than 1, both its upper limit and the lower limit, then we would say that there's a definite negative association or negative effect for whatever we are estimating. Now, if the confidence interval includes the null value, so let's say, for example, the point estimate of the risk ratio, let's say, was 2, and your confidence interval ranges from the lower limit, maybe let's say it's 0.7, and the upper limit is 4. So if your confidence interval around 2 risk ratio, if it's 0.7 to 4, then this 0.7 to 4 includes the value 1. So then what it means is that the risk ratio could be less than 1 or the risk ratio could be more than. And hence, we are not really sure whether there is an association or not. In another scenario, it is possible that the confidence interval may contain the null value, but most part of the confidence interval is towards the right side. So if we take the same example as before, so if your risk ratio is 2 and the confidence interval around that is from 0.9 to, let's say, 6, then what we would say that the risk ratio is more likely to be positive than negative. And hence, such a confidence interval tells us that our value of 2 is consistent with a positive association. On the other side, again, if it may contain the null value, but majority of it is towards the left of the null. So maybe you have a value from, let's say, 0.3 to 1.5, but majority of it is less than 1, below 1. We cannot just ignore this confidence interval. We would still say that this seems to be consistent with a negative effect or a negative association. We may not be definite about this positive or negative association, but there is a high consistency if your confidence interval majorly is towards one side or the other. Further, we need to also interpret this confidence interval not just based on its own value, but also based on what is the practical significance, either the clinically or say in public health or in terms of whatever we're going to measure. Does it make sense? So again, here, if you see, if we put this green region denotes a range of practical interpret, which means if the values fall anywhere in this range, actually make a difference to the outcome. And so it can be ignored. If we have a confidence interval which fully lies within this range of practical indifference, the results that you get from the study actually do not make any difference, and you need to just keep doing things the way you've been doing. If you have a very wide confidence interval, and some part of it is beyond this range of practical indifference, although it seems that yes, it could be important, but since the confidence interval is very wide, so which means that it's not as precise. The estimate that you're calculating, whether it's a odds ratio or a risk ratio or even a mean or median, so it can be ignored because probably the sample size is too small to make a meaningful interpretation. It could be that we have a very good sample size, and there's also a positive effect, which means the confidence interval falls entirely towards the right side of the null value. It's higher than 1 for, say, a ratio measure. Then, yes, there is a positive effect, but it is of no practical significance because having any of these values doesn't change what is already going on. However, if you have a confidence interval, let's say, which shows a positive effect, and it's also the values are outside of this range of practical indifference, then it really makes sense. And we can say, yeah, this is an important finding that yes, there is a positive effect. It is pretty precise because the confidence interval is relatively narrow, and it's also of practical importance. Now let us look at an example here where we try to understand these confidence intervals. This is again from the paper by Whitley and Ball on their statistics review for related to hypothesis testing and p-value. As the same question that we asked earlier in the p-value session. So if we want to know whether in patients with acute myocardial infarction, does the administration of intravenous nitrate as compared to not giving anything reduces mortality? These are the 6 studies and results from the 6 studies that were published in different journals, and then it was brought together by Yusuf et al. In paper in 1988. And here you see, you have the 6 trials. You have the number of dead divided by the randomized for the intervention group, which is the intravenous nitrate group, and the control group where nothing was given. You have the sample size, say for in the Quiche trial, you have a sample size of 50 in the intervention arm and a sample size of 45 in the control arm. Out of these 53 individuals were dead even after administering intravenous nitrate, whereas in the control arm, 8 individuals died when nothing was administered to them. You have an odds ratio, you have a 95% confidence interval around this odds ratio, and you have a p-value as well. Now, if we look here, the odds ratio for the Quiche study, first one, is 0.33. What that means is that the intravenous nitrate, it reduces mortality by 2/3. However, if you look at the confidence interval here, which ranges from 0.09 to 1.13, that indicates that the true effect would be a reduction in mortality of 91%. That is based on 1 minus OR of the lower limit, which is 1 minus 0.09. It could also mean that administering intravenous nitrate would result in increase in mortality by 13%, as denoted by the higher confidence limit of 1.13. As you can see, the confidence interval here, this is the 95% confidence interval. It ranges now from 0.09 to 1.13. and includes the null value of 1 as well, which signifies an uncertainty in the odds ratio of 0.33. So if we were to take this as the final result, it could actually be a problem, because it is possible that maybe administering intravenous nitrate could actually be dangerous to the patients, although not too much, but there's still a likelihood that higher number of people may die compared to not giving intravenous nitrate, as per the results of this trial. Here also we note that the confidence interval is pretty wide, 0.09, which is very close to 0, and crossing the 1 and going to 1.1, which also reflects there is a lack of precision in the estimation of this odds ratio of 0.33. And the reason for that, as you can see here, is the small sample size of 50 and 45 in the intervention and the control arm. Now, if we look at the next study, the Busman study, where you have an odds ratio of 0.24 and a confidence interval of 0.08 to 0.74. What this indicates is that there is a reduction in the mortality. The reduction in mortality due to administration of intravenous nitrate could be as low as 26%, which is 1 minus 0.74, or it could be as high as 92%, which is 1 minus 0.08. Definitely, what that means is that administering intravenous nitrate is beneficial and it will not be. Again, the 95% confidence interval does not include the null value of 1. And so we are pretty certain here of this estimated odds ratio of 0.24, which signifies a 66% reduction in mortality, which is our best bet from this study. But again here, although the confidence interval is towards the left side, it shows a negative effect, which is something that is desirable. However, you can see that it is still pretty wide. It goes from 0.08 to 0.7. So again, this is a result of the small sample size, as you can see here, 31 in the intervention group and 29 in the control. Now, if we look at the last trial in this list, the Jagpat trial, the odds ratio for the effect of intravenous nitrate on mortality among acute MI patients is 0.48, reflecting almost a 50% reduction in mortality. The confidence interval here is 0.28 to 0.82, right, indicating a reduction in mortality between 18% and 72%. Of course, all of it is towards the left side of the null value of 1, does not include 1, and the confidence interval itself is relatively narrow. If you now compare that, say, for example, the Busman study, 0.08 to 0.74, this is narrower, 0.28 to 0.82. And so we can say that this results of this trial, this odds ratio of 0.48 is much more reliable compared to, say, the odds ratio of 0.24. Although both the studies show a definitely negative effect or a preventive effect of intravenous nitrate on mortality. Now, why are we seeing this narrower confidence interval? If you look at the sample size, we have 154 patients in the intravenous nitrate arm and 156 patients in the control arm, which is much, much more than the Busman trial, where you had only 31 and 29 respectively. Thank you.